We are now at question 4, part A, CSEC Maths Exam January 2012 video solution. The question speaks of a bus schedule where the bus departs from Bellevue at 6:40 a.m. and arrives at Shackville at 7:35 a.m. It then departs Shackville at 7:45 a.m. and arrives at St. Andrews at 8 a.m. Right? And then there are a series of questions. Now the first question is asking the time spent at Shackville. Now if the bus arrives at Shackville at 7:35 and then departs at 7:45, it means that it spent 10 minutes at Shackville. 7:35 a.m. to 7:45 a.m. That's 10 minutes spent at Shackville. So the answer there is 10 minutes. Part 2 is asking us how long the bus took from Bellevue to Shackville. The time from Bellevue to Shackville. Now, if the bus left Bellevue at 6:40 and arrives at 7:35, it means that it would have traveled 20 minutes to get to 7 o'clock and then 35 more minutes after 7 o'clock. So that's a journey. 20 minutes between 6:40 and 7 o'clock, and then 35 minutes from 7 o'clock to 7:35. Right? So we can show that calculation, the time that it took from Bellevue to Shackville. 20 minutes plus 35 minutes. So the bus took 55 minutes to travel from Bellevue to Shackville. That's the answer for that part. Now there's some additional information in part 3. Part 3 says the average speed from Bellevue to Shackville is 54 kilometers per hour. Remember that it took 55 minutes to go from Bellevue to Shackville. So traveling at 54 kilometers per hour for 55 minutes, they want us now to calculate the distance between Bellevue and Shackville. Let's break it down. The bus will take 60 minutes to travel 54 kilometers because the speed is 54 kilometers per hour. 1 hour is 60 minutes. So the bus will travel 54 kilometers in 60 minutes. So how far will it travel in 1 minute? In 1 minute, it will therefore travel 54 divided by 60. Well, 54 divided by 60 is 0.9. So in 1 minute, the bus will travel 0.9 kilometers. We're simply dividing through by 60. All right. And so in the 55 minutes that it took to travel from Bellevue to Shackville, it would have traveled 55 multiplied by 0.9 kilometers, because if it took 1 minute to travel 0.9 kilometers, then 55 multiplied by 0.9, that's the distance it will travel in the 55 minutes, right? 55 multiplied by 0.9, so that is 49.5 kilometers. So that actually is the distance between Bellevue and Shackville, traveling at 54 kilometers per hour, and it traveled for 55 minutes. 55 minutes at 54 kilometers per hour, it will travel 49.5 kilometers based on this breakdown. And so the distance from Bellevue to Shackville is 49.5 kilometers. And that is the end of question 4A. Question 4B now tells us of a cylindrical bucket with a base area of 300 centimeters squared. So the base area, we have done a schematic for the cylindrical bucket. So it's a cylinder and the base area is 300 centimeters squared. And the question said that 4.8 liters of water is poured into the bucket. 4.8 liters of water is poured into the bucket. And we're asked to find the height of water in the bucket that's represented here on this diagram. So this is the water in the bucket, this is the base area, and this is the height of water in the bucket. And there's 4.8 liters of water in the bucket. Now because we are given the area in centimeters squared, right, what we need to do is see how much centimeter cubed the 4.8 liters of water represents. Right? Now 1 liter is 1000 cm cube in volume, right? And therefore the 4.8 liters is 4800. We simply multiply by the 4.8. So 4.8 liters is 4800 cm cube. So the volume of water here is 4800 cm cube. And the volume of water is given by the cross-sectional area, which is now the base area here, multiplied by the height. That's the volume of this cylindrical object now formed by the water. Cross-sectional area multiplied by the height. Alright, and that will equate to the volume of water in the bucket. Cross-sectional area, which is the base area, multiplied by the height. That's the volume of water in the bucket. And that's what we need to express. The volume of water will be the base area multiplied by the height. And we know that that's 4800. Alright, so if we divide by the base area, we will make the height the subject, and that's how we can calculate the height of the water in the bucket. Alright, the base area is 300, so we'll now put the 300 in. So it's 4800 divided by 300, and we end up with 16 centimeters. So the height of water in the bucket is 16 centimeters, and that's the answer for question 4b. Now let's move to question 4c. Question 4c tells us of a cuboid with a length of 13 centimeters, a width of 4 centimeters, and a height of h centimeters. Right? And we're asked in part 1 to state the area of the shaded face, the area of this face right here. We're asked to state the area of this face, which is shaded in the diagram. Right? So the area is simply, that's a rectangle, so the area of the face is simply the product of the width and the height. So that's 4h centimeters squared. Alright, so that's the area of the face here. And then we're asked to write an expression in terms of h for the volume of the cuboid. The volume of the cuboid is therefore the end area multiplied by the length. The end here now would be a uniform cross-section, would be the cross-sectional area. So the cross-sectional area, which is the end area, multiplied by the length, that will give us the volume, and we'll have it in terms of h. And we already calculated the face area to be 4h. And so the volume of the cuboid is 4h multiplied by 13. And that works out to 52h centimeters cubed. 4 times 13 is 52 times h. So it's 52h centimeters cubed. Right? That's the unit for volume. Centimeters cubed, because it is centimeters multiplied by centimeters multiplied by the height, which also is in centimeters. But the height is actually h centimeters. Part 3 now is telling us that the volume of the cuboid is actually 286 centimeters cubed. So it means that this 286 is equal to this 52h. And that's what we're going to use to find h. We're going to equate the 52h to this 286, because that's the expression for the volume of the cuboid. And they are told now that the volume is actually 286 cm cubed. So we can go ahead and equate those two things, the 52h and the 286. And then now if we divide by the 52, we end up with h being equal to 286 divided by 52, and therefore the height is 5.5 centimeters. The h is actually 5.5, right? But the height, the question asks us for the height. The height is 5.5 centimeters. The h is 5.5. The height is 5.5 centimeters. The value of the h is 5.5, because the question actually did say that the height was h centimeters. So h is 5.5. The height is 5.5 centimeters. And that's the answer for question 4c. Alright, so next we'll do question 5 in our next video. Alright, see you then.